Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on graphing functions. And if you find this video helpful, please consider smashing the like button, subscribing, and checking out my other videos. So let's get going. Today in particular, we're going to talk about graphing logarithms. Now, logarithms is kind of one of those terms that tends to scare many students, but that is mostly because I don't think we do a really good job at emphasizing what they actually are. So students feel like they're being asked to graph something or algebraically work with something that's just a bunch of letters and symbols on a paper and they don't know what it is. So that really brings us to the question of, we want to ask, what are logarithms? And to get at that question, you really need to go back to exponential functions. So what is an exponential function? It is, if a and b are real number constants, an exponential function of x is a function that can be written as f of x equal to a times b raised to the power x. And then there's some other constraints on our constants here. And b is called the base. Now, our students tend to have a pretty good understanding of exponential functions. It's 2 to the x. If I plug in values for x would mean, okay, if I plug in 5, raised to 2 to the 5th power. Oh, 2 times 2 times 2 times 2 times 2. I've just multiplied 2 5 times. So students tend to not have an issue getting points for exponential functions. But why does this have to do with logarithms? And it has to do with logarithms because they are the inverse functions to exponential functions. So, how they relate is the inverse of the exponential function f of x is equal to b to the x is the logarithmic function of base b. So when we write log base b of x, that's just the inverse function of b to the x. And that just means if you want points on your logarithm, just switch the values from your exponential function of base b. And I have the rule here of how x, y, and b all relate. But the key is, let's look at some problems that actually deal with graphing logarithms. So if you don't understand logarithms, make sure you understand exponential functions, because you can build on that to understand logarithms. If you don't understand exponential functions, you need to go back and study those before you can really understand a logarithm. So let's look at two examples of how to graph logarithms. First, let's look at log base 2 of x. And to understand the graph of this logarithm, you need to understand the graph of the exponential function y is equal to 2 to the x, which I have drawn the graph here. So make sure you're comfortable with this graph first. So if you want to graph a base 2 logarithm, all it means is take the points on your curve of 2 to the x and switch the x and y coordinates, because that's one way our graphs relate inverse functions. So to do that, the first thing I always am going to change is the asymptote. Instead of y is equal to 0, because I'm switching x and y, x is equal to 0 becomes the asymptote on our logarithm graph. So x is equal to 0. Once you've done that, look at your points. So I had a point at negative 1, 1/2. So 1/2, negative 1 will be a point. I have a point at 0, 1. So 1, 0 will be a point on our logarithm. I had a point at 1, 2 on my exponential function. So 2, 1 will be a point on my logarithm. Similarly, 2, 4 is on my exponential. So 4, 2 will be on my logarithm. And 3, 8 is on my exponential. So 8, 3 is going to be on my logarithm. And this gives you a bunch of points to give you a nice picture of our logarithms graph. So I was able to get this logarithm really quickly just by understanding and knowing these points on my exponential functions graph. Now, typically you're going to have to graph transformations too, but that's a different video, and you need to make sure you understand the base functions first, and a lot of students don't even understand the base function. So this is one logarithm you'll deal with. Another logarithm you'll probably see is called the common logarithm, otherwise known as base 10. So base 10 logarithms, because they're called the common log, we usually drop the little subscript here. So when there's no subscript in your logarithm, you can interpret that as base 10. So that means if I need to graph log base 10, I need to understand the graph of the exponential function 10 to the x really well. And you'll notice my graph is off the grid a little, but that's fine. Different scale logarithms make it harder or easier to graph. But you'll also notice I'm putting a lot of parentheses in because adding parentheses is really useful for exponential functions because you can emphasize what's being raised to that power, and with logarithms because you emphasize what is inside of the logarithm. But it's the same process as before. Just switch your x and y coordinates, switch the asymptotes. So instead of having an asymptote at y is equal to 0, you end up with an asymptote at x is equal to 0. And switching the points, there's a point at negative 1/110. So that means 1/10 negative 1. So something like that will be a point on our common logarithm. 0, 1 is a point on our exponential function. So 1, 0 is a point on the common logarithm. And 1/10 is a point on the common logarithm. So about 10, 1. So something all the way out here is going to be a point on our common logarithm. And you end up with a graph like this. So, and you might have a different scale to make it a little bit better, but it's the same process no matter which logarithm you want to graph. It really just boils down to knowing its exponential function well. I cannot stress that enough. If you don't understand how exponentials and logarithms relate, you're not going to understand what a logarithm is. Another thing you can do to check to make sure your work is right is to recognize that when you had inverse functions, their domains and ranges flip-flop. So with our exponential functions, we knew that the domain is always all real numbers. So that means the range of our logarithms will be all real numbers. Likewise, the range of our exponential functions here was 0 to infinity. So that means the domain of our logarithms is going to be 0 to infinity. Now, these numbers can change a little when you talk about graphing transformations of logarithms, but that's a different topic altogether. So, on a whole, my tips for you with graphing logarithms is to make sure you understand exponential functions well. If you don't, you're not going to understand logarithms. Recognize that all a logarithm is it's an exponential function, but switch the x and the y coordinates, because that's how inverses relate. When you do a graph the vertical asymptote first. You can use domain range to check for mistakes. The logarithms I think you should be very familiar with is base 2, base 3, the common logarithm base 10, which is denoted by dropping the subscript, and the natural logarithm, which is a base e logarithm, and that's going to be denoted by this ln of x. So you can think of that as logarithm natural if you want. That's how I can remember the letters. And always use parentheses to denote what's inside of your logarithms. And if you do these, I think that it'll help you get very good at graphing logarithms very fast. So I hope you found this video helpful. So if you did, make sure you hit the like button and check out some of my other videos, and have an awesome day.